Okay, thank you very much. Welcome everybody. We're going to be going over the PPM and drainage manual changes today. And a lot of these came from efforts that we did with the district. Okay. There we go. Okay. Can you get that? I'll get that out of there. Okay, there we go. We were charged last year with taking the various criteria from the districts and looking at them to see what was worthy of statewide endorsement, what was perhaps regionally specific, and what was perhaps a preference that ought to be let go of. So last April, we met with all the districts for a day and a half, and we went through all their policies. It was a good time, very fruitful. And there's more changes than what I'm going to tell you here today. These are the bigger ones. And you can see here a link should you want to find all the changes that's on our website. So again, kudos to a lot of the districts for a lot of what you're going to see today. Okay. First of all, in PPM Volume 1, there's an issue that we've been working with for a long time where for super elevations on the high side as you're turning, you go through a 0% cross slope, which is poor for stranding water on the pavement, and of course you have a hydroplaning potential. In the AASHTO Green Book, in Chapter 3, there was, in that case, a required 0.5% longitudinal slope in those areas to minimize the duration of the 0% cross slope. So that got moved into the PPM Volume 1. We also had a wildlife issue where in some cases there were shelves being put in drainage structures, kind of a dual-use structure. And it wasn't very friendly to the creatures, like that nice doe there. So at this point, we are saying don't put the shelves in the drainage structures and try to double dip for wildlife crossings. If, however, you are on a floodplain somewhere, like in D3, and you have a wildlife crossing up there, understand that when the river stages up, you will have a floodplain crossing there, hydraulic crossing. That's okay. Just don't put the shelves in there. Wildlife structures designed for wildlife can be used for drainage, but they need to be designed for the wildlife. Okay. In Volume 2 of the PPM, we put in that drainage maps were required anytime that projects add capacity or there's significant changes to the drainage. And we want them on aerial bases. Years ago, we went away from aerial bases because in hard copies, repetitive hard copies of plans, they quickly became illegible. But now with the electronic plans, we can go with aerial bases for the drainage maps, and those are invaluable to the next generation of hydraulic engineers. There's so many details that we pick up off an actual aerial photo, and we want to stick with them. We want to include that in any of the contract plan submittals. We had some cases where flood data summary boxes were being put in where there was no real change in the hydraulics of the area, and we don't need to do that. So we only want flood data shown for the cross structures where there's modifications that affect the existing hydraulics. We don't need to pull old, unchanged information and put it on new plans. Likewise, we found one thing we did not need it when we're extending pipes. In Spec 430-4.1, it says when extending existing pipes, construct the pipe extensions of the same size and kind as the existing pipe. And so if that's what the spec says, we don't need to tell the contractor twice. We don't need to include those extensions with like materials in the optional materials tabulation sheet. It's redundant. There's already guidance in the specs. Okay, going on to the 2013 drainage manual. This was released in January, maybe even January 2nd, marvelously. And we're going to continue to try to do that release in January 2nd. Here's some of the changes. For storm drains, the pipe slopes, as you know, we target pipes flowing full under gravity. South Florida often never sees that. They see pressure flow usually. And South Florida being flat, District 4 down there had a criteria that instead of 2.5 feet per second as the target design velocity, they were going down to 2.0. They weren't having problems with it. So we brought that into the drainage manual as a hardship case for when the ground is very, very flat. Sometimes it's just very hard to get a 2.5 foot per second velocity. Verify with the DDRE whether it's not a hardship case in design build situations. That will be in the RFP. Now, as the hydraulic engineers know, you can push water up an adverse slope by differential head between the headwater and tailwater. But we want the sediment to move downstream into the next hydraulic drainage structure where it can be captured more easily rather than being clogged in a pipe. So we put a physical slope requirement of 0.1% on pressure flow pipes. That way we can move the sediment and hopefully the pipes won't get clogged as bad. Our friends from the Turnpike gave us a nice parking lot drainage policy. No surprise there that they would be all over that. And it was focused on pedestrian safety, mostly where to put inlets, where not to put them. Very common sense. You know, don't have a crosswalk and then have a curb inlet sitting right there where somebody can step down and step right into it. Very practical, common sense, section 3.7.1.1. There were shoulder gutter locations that were out in the handbook, which we brought in. It was very authoritative, and it's different combinations of height and longitudinal slope where shoulder gutters required, including super elevation. The drainage manual, section 3.7.3. We also addressed temporary drainage in construction. In talking with our construction folks, they were doing a fairly simple, flexible approach, kind of common sense rather than deeply numerical approach to spread in construction, and we really were not having problems. So we mimicked that in the drainage manual and then put a flag for more difficult situations. Difficult situations would be where perhaps you have a large area draining to the to a low point in the construction area. That would tend to be flood sensitive. Also, high-speed facilities, when you hit 45 miles an hour and greater, and definitely 55 and greater, you start to get more hydroplaning potential. So we want to look at that more closely. And we also saw that for low-side barrier wall, especially with weaving, that we could sometimes have a more difficult hydroplaning potential. So we flagged those three areas: flood sensitive, typically large areas coming to one point, high-speed facilities, and low-side barrier wall as worthy of more attention. And the drainage engineers will define that. District 6 gave us some great French drain placement advice. Again, very common sense. They had a nice criteria for how close French drains could be to overhead signs, drilled shafts, other structural members. And very nice. We brought that in. They also had some common sense factors that should be considered for French drain placement. For instance, don't plant trees right above a French drain, right? We all know that, but they actually had that down. The cost of replacing the French drain in the future. We know that French drain doesn't function as well under pavement, so think about that. It's not that we can't do it, it's just not our first choice. So thanks to D6 for that. D7 had pioneered resilient connectors, which have been allowed for years. They've been in the spec book for years, but typically contractors will mud up the connection, hopefully with a brick at the bottom to center it. D7 wanted a better connection, and so they pioneered the use of mandatory resilient connectors, and they learned some lessons there about what was available and what wasn't. For example, resilient connectors aren't made for elliptical pipes. Don't ask for one. Things like that. Resilient connectors are not readily available with more than a 15-degree connection angle. So they helped us out with that. We brought it into the drainage manual. It was good advice. Okay, and for cross-drain hydraulics, the turnpike had a 100-year stage on the mainline turnpike. It was something they adopted to strengthen their bond standing. And who could argue that the turnpike is not the main artery for north-south evacuation during storms? And so we let that stand. Again, we think they made a great decision there. The reference for emergency access was formally removed. That doesn't mean that roads can't be assigned a higher design high water frequency. Doesn't mean we can't do that, but the emergency access was a bit inconsistent across the state. And again, a reminder for coastal roads. For inland storms, we can elevate, and overtopping can do some damage. It's not a great day when that happens, but roads survive. For coastal roads, remember that we do not elevate coastal roads. And this is the reason why. When coastal roads overtop, when a hurricane moves in and the storm surge moves in, especially on the ebb flow, we can get this kind of overtopping and damage if the road is elevated around the surrounding land. So we try to get coastal roads down at about the same elevation of the surrounding land. We can also have wave attack on coastal roads. And so we would rather have to blade off the road at the end of the storm rather than have to rebuild it. So again, be careful with coastal roads. Do not raise them unless you have a specific reason to, and unless you're willing to pay for the kind of armoring that can help them survive after a storm. Okay. We changed the target for standard rubble. What happened was that we started to have occurrences where our current target specific gravity of 2.3 was being narrowly missed. We were seeing 2.5s, 2.7s, I'm sorry, not 2.25, 2.27, 2.23. And so what the SMO and I did on a project-by-project basis, we started dropping the specific gravity, making sure that the design conditions would tolerate it. And we decided, well, let's just drop the specific gravity to 2.2, and the values of velocity and the wave heights, significant wave height up there that you see, are the new design targets for specific gravity rubble of 2.2. That's the same size as our current blanket. Now you'll notice that the spill-through abutment has a higher allowable target velocity. The reason is that the spill-through abutment doesn't create as much local energy as a bulkhead type of abutment. Those velocities are the local velocities. For instance, don't use the average velocity across the stream. Take a look at what's happening right upstream of your revetment. In the same way, rectangular piers and pilings have a lower design velocity allowance, and the reason is because that vertical face causes more local vortices and can displace rubble as opposed to a circular shaft. So those values are in the drainage manual, and that should still warrant the use of standard rubble for most Florida applications. Interestingly, we also found out that as long as material was available, and we didn't have to truck it in. The size was not a big issue, so we're sticking with our current size. Okay, this was a fairly big change. District 4, for many years, had not used Rule 1486 on internal projects. Now, we still always use 1486 for offsite inflows, and the reason for that is because offsite inflows to a storm sewer system are much more sensitive than, say, our flows to a water management district canal or a ditch. You can easily compromise and surcharge a storm sewer system with the 18-inch laterals and get hydroplaning problems. And so we still keep the more rigorous 1486 for offsite inflows, but for department projects, for our internal designs, for our projects, we're only invoking Rule 1486 with its multiple storms where we're in closed basins, which are obviously more flood prone, or in areas where there's clearly flooding going on already. For instance, if your project is flowing to an area which has been flooding in the 10-year storm, and you know we have an issue, that's a time to invoke the more rigorous Rule 1486 sizing of the facility. Again, the DDRE will provide direction, and for design build situations, it will be upfront in the RFP. And so the idea here is not to waste money in over-designing when we're not having problems. And again, thanks to District 4, we had a pretty good long-term test case to check that out. Okay, and I think lastly, the polyethylene pipe class 2, which is our 100 years target, the industry finished the testing for long-term acceptance. The tests involved long-term modulus testing, which took a good bit of time, several years. And so the interim restrictions were removed. You may remember that those restrictions were that the polyethylene pipe was not to be used for 100-year service life under interstates, 8-lane sections, adjacent to buildings, things like that. Those interim restrictions are removed, and the only restriction is that the Class 2 polyethylene pipe is still not allowed in the Keys, and that's due to the service temperature. The original computations that industry did not target the elevated temperatures in the Keys, and so they've elected not to redo that testing, so at this point they're still not allowed in the Florida Keys. Okay, and now some questions and comments. Is the 0.5% minimal longitudinal slope requirement referring to the PGL or to the entire travelway? We would like to see that, and I might enjoy Frank's comment on this. The idea is that the whole transverse cross slope at that point is subject to 0% cross slope, and I think we would want to see that 0.5 longitudinal slope across the whole typical section where it goes flat, and not just the PGL. And Frank has given me a thumbs up. Okay, I'm not a drainage engineer. Well, I feel sorry for you. Just kidding. Okay, I'm sorry. I'm not a drainage engineer and would like to obtain a link for the 2013 drainage manual. Can you tell me where to obtain it? Yes, I can. And if I can get, let's see, you can obtain it if you go back to this initial slide right there. If you just click this part, you'll find that will get, I'm sorry, up to the DR. If you end it at the DR, that will get you to the main drainage page, and then go in under handbooks and manuals, and you'll find not only the 2013 drainage manual, but I think we still have down to 2009. Not sure about that, but other years as well. So that's where it is. Let's see. Do you have an update on a potential sidewalk cross drain standard that eliminates the drop-off hazard. And those hideous pipe guide rails we have now. You talk about the aluminum handrail, I bet, and you're probably okay. You're talking about the back of sidewalk and probably the closed flume inlet, both of which have a handrail. Yes, we are working on that. We think that we may be able to put a little lip there for ADA benefit, and thereby be able to eliminate those. That has not been a high priority, but obviously somebody else thinks that they're hideous, and and maybe you're right. So we do have something. Oh, and it's from David O'Hagan. David David's good to hear from you. David, you've got us there. This was one of David's pet peeves. And so David, Jennifer has been working on it. Other priorities have moved ahead of it. Will it be removed, or you think it will be removed in the 2013? Maybe. But
that's what Robert said.
Is that what Robert said? Okay. Well, David, it sounds like it maybe has a higher priority than I thought. So, okay. Thank you, David. I hope all is well. Nice to hear from you. Any other questions? Oh, okay, here we go. Is steel HDPE being evaluated for acceptance as an optional material? Yes, it is. That's the Context Duramax by name. And we are looking at it, and it appears that we will bring it in. We're still in the final stages of that. And Mario Paredes from SMO and I have been working on that. And so I believe you'll end up seeing it soon. We should ask if somebody from Contech asked that. It's okay if it is. Anybody else? Any other questions?
We do not have any other questions at this time.